Have you ever wondered what exoplanets are and why they are important in the search for extraterrestrial life? Picture this. Our solar system is but a tiny speck in the vast cosmic landscape. Just as we have planets orbiting our sun, there are countless other stars out there, each with their own planets. These planets outside our solar system are what we call exoplanets. And now the universe is incredibly vast. So vast, in fact, that it's likely there are more exoplanets out there than grains of sand on all the beaches on Earth. Imagine that. Each of these exoplanets presents a new opportunity, a new world to explore, and perhaps a chance to answer one of humanity's oldest questions. Are we alone in the universe? So, now that we know what exoplanets are, let's delve into why they matter. The first exoplanet was discovered in 1992. Fast forward to 2024, we now know of over 4,000 exoplanets. How did we go from 1 to 4,000 in a little over 3 decades? The answer lies in the evolution of technology and scientific methods. Back in the day, finding a planet outside our solar system was like finding a needle in a cosmic haystack. Astronomers had to rely on indirect methods, such as monitoring the slight wobble of a star caused by the gravitational pull of an orbiting planet. This method, known as radial velocity, was the key to the discovery of the first exoplanet. But as technology advanced, so did our ability to explore the cosmos. Enter space telescopes like Kepler and TESS. These marvels of modern technology have taken exoplanet hunting to a whole new level. Kepler, launched in 2009, was specially designed for finding Earth-like planets orbiting other stars. It used the transit method, which involves detecting the tiny dimming of a star as a planet crosses in front of it. This method not only allows us to find exoplanets, but also to determine their size and orbit. TESS, or the Transiting Exoplanet Survey Satellite, took over from Kepler in 2018. It's on a mission to survey the brightest stars near the Earth for transiting exoplanets over a 2-year period. TESS is expected to catalog more than 20,000 transiting exoplanets, including 1,000 or so that are approximately Earth-sized or super-Earth-sized. The contribution of these space telescopes to the field of exoplanet discovery cannot be understated. They have not only expanded our knowledge of the universe, but have also ignited our imagination about the possibilities that lie beyond our own solar system. As we continue to discover more exoplanets, we are constantly refining our understanding of the universe and, perhaps more importantly, our place within it. The search for exoplanets isn't just about finding new worlds, it's about exploring the possibility of life beyond Earth. Each new discovery brings us one step closer to answering the age-old question, are we alone in the universe? Exoplanets come in all shapes and sizes. They're as diverse as the galaxies they inhabit, and their variety is a testament to the incredible complexity of the universe. Let's dive into this cosmic variety show and explore the different types of exoplanets. First up, we have the gas giants. These are similar to Jupiter and Saturn in our own solar system. They're enormous planets, mostly made up of hydrogen and helium. Their size alone makes them relatively easy to detect, but don't be fooled. Their gaseous nature means they're unlikely to host life as we know it. Next on our cosmic tour are the ice giants. Think of Uranus and Neptune. These planets are characterized by their thick, heavy atmospheres of water, ammonia, and methane. The ice in their name refers not to water ice, but to a hot, dense fluid of these elements under high pressure. Moving on, we have rocky planets akin to Earth, Mars, Venus, and Mercury. These planets have a solid surface, and it's on these types of planets where we hope to find conditions suitable for life. They're smaller and harder to detect than gas or ice giants, but they're out there, waiting to be discovered. Finally, we have the dramatic lava worlds. These are rocky planets that orbit so close to their stars that their surface is molten. In other words, they're covered in oceans of lava. While these planets offer a spectacle of cosmic fireworks, they're not exactly prime real estate for life. But the story of exoplanets doesn't end here. Each category has subtypes, and there are even more exoplanet types that don't fit neatly into these categories. The universe is a place of endless variety and possibility, and every discovery adds another piece to the puzzle of understanding it. These variations in types increase the odds of finding planets with conditions similar to Earth. Each type of exoplanet provides us with information about how planets form, evolve, and importantly, whether they can harbor life. Understanding these types is crucial in our search for life beyond Earth. The more we learn about these distant worlds, the closer we come to answering the question, are we alone in the universe? Not all exoplanets are created equal when it comes to the possibility of life. As we delve deeper into the cosmos, it becomes increasingly important to understand where to look for signs of life. This brings us to the concept of the habitable zone, or as it's often fondly referred to, the Goldilocks zone. Now, why the name Goldilocks, you might wonder? Well, it's a nod to the classic fairy tale where little Goldilocks prefers her porridge not too hot, not too cold, but just right. In astronomical terms, the Goldilocks zone is that just right region around a star where it's not too hot, not too cold, and conditions might be perfect for liquid water to exist on a planet's surface. You see, water is the key to life as we know it. On Earth, wherever there's water, there's life. So, astronomers believe that the presence of liquid water on an exoplanet could potentially signal the existence of life. But let's make it clear, the Goldilocks zone is not a one-size-fits-all concept. It varies from star to star, depending on the star's size and temperature. For instance, a smaller, cooler star will have a closer habitable zone, while a larger, hotter star will have a farther one. Now, just because a planet is in its star's Goldilocks zone doesn't automatically mean it's teeming with life. There are many other factors to consider, including the planet's atmosphere, its geological activity, and the presence of a magnetic field to protect it from harmful solar radiation. So, finding a habitable zone is just the first step in a long, complex process of determining whether an exoplanet could host life. Astronomers use sophisticated telescopes and instruments to analyze the light from these planets, looking for signs of water, oxygen, and other potential indicators of life. Finding a planet in the habitable zone doesn't guarantee life, but it's a good place to start looking. And who knows? One day we might just find that we're not alone in this vast universe. The search for exoplanets and life beyond Earth is far from over. The future of exoplanet exploration holds a universe of possibilities, quite literally. As we venture deeper into the cosmos, the potential for discovery grows exponentially. The next generation of missions and technologies is set to revolutionize our understanding of exoplanets and their potential for life. For instance, let's consider the upcoming launch of the James Webb Space Telescope. This scientific marvel will allow us to peer deeper into the universe than ever before, and with unparalleled precision. It's designed to capture the faintest glimmers of light from distant exoplanets, potentially revealing the chemical signatures of life. And then we have the Large UV Optical Infrared Surveyor, or LUVOIR. This proposed space telescope could take exoplanet exploration to an entirely new level. With its advanced imaging capabilities, LUVOIR could potentially capture direct images of Earth-like exoplanets, providing us with a wealth of information about their atmospheric composition and possibly signs of life. But let's not forget the ground-based observatories like the Extremely Large Telescope, currently under construction in Chile. Once completed, it will be the largest optical/near-infrared telescope in the world, capable of detecting and studying potential biosignatures in the atmospheres of exoplanets. And these are just the big names. There are countless other missions, technologies, and initiatives in the works, each with the potential to transform our understanding of the universe and our place within it. The road to discovering extraterrestrial life is paved with challenges, but every challenge is an opportunity for innovation. It's a thrilling time to be part of this cosmic journey. We're not just looking for new worlds, we're seeking answers to some of the most profound questions of our existence. As we continue to explore these distant worlds, who knows what we'll discover next? The universe is full of surprises, and our search for life is just beginning.